In this video, we will continue using the properties of similar triangles to find unknown sides or angles. This is part 2 of the video. We've already done problems 1 through 6. So if you have not seen part 1, go back and watch that first. Before we get started, let's practice a concept that's going to show up again and again during this video. And that's the relationship between a whole length and its two parts. So for example, if I knew that the whole length was 10, if I told you that this part was 6, then of course you could tell me what the other part is. Alright, right now you're thinking 4. But you got that by doing 10 minus 6. Alright, so I want you to get comfortable with how these are related to each other. So let's say if I turn this into an x, an unknown. Alright, this still represents the whole. So if I told you that this was 6, then you would know that whatever this x is, the other part is going to be the whole minus the part that you already know. When it was 10, this was 10 minus 6. But if this is x, then we will have to call this x minus 6. Okay? And of course it would work on the other side just as well. Whatever this is, if I told you that this was 8, you would know that the other side would be x minus 8. On the other hand, what if we knew that the whole was 10, and now we want to talk about expressions for these two parts. So if this is x, then what is this going to be? So remember, this part over here is going to be the whole minus the first part. So in this case, the other part would be 10 minus x. Okay? And similarly, if the whole is 10, and I told you that this part over here was x, well, you know what, let me change the numbers a little bit. Let's say I told you that this was 23. If this part over here is x, then this part over here is going to be 23 minus x. Okay, does that make sense? Just one more time, just if I replace these x's with actual numbers, it will be really clear to you. If I told you that this was 10 and you needed to figure out what the other side was, you're probably thinking right now that, well, the other side must be 13. Alright, 10 and 13. But what you're really doing is you're doing 23 minus 10. Okay, so if we don't know exactly what it is, so we have to call it x, this side will still be the whole minus x. Alright, I hope you're comfortable with that because that's going to show up a lot. So, on problem number 7, we have a triangle inside of a triangle. I'm going to highlight the two triangles. Okay, I'm going to refer to the smaller red triangle as the old triangle, and I'll refer to the larger green triangle as the new triangle. And that's just so I can think of my proportions in terms of new over old equals new over old. Alright, that's the formula that I always use. So let's look for corresponding sides. I am going to go ahead and call this x instead of question mark. So let's go ahead and look at this side where the x is. I need to do new over old. The new side is the green side, so that's going to be 28. Let's see, can I squeeze this in? Yeah, I can fit it in over here. So new over old, so that'll be 28 over x. Alright, those are corresponding sides. Now, I see we've got these numbers over here, the 12 and the 16. I need to do new over old, the large green side divided by the red side. So that's going to be 16 over 12. I prefer to reduce these fractions, so I'm going to have 28 over x equals, okay, and both of these are divisible by 4. So if I do 16 over 12, this should be 4 over 3. So I'm going to get 4 over 3, and then we cross multiply. So we will do the yellow diagonal, we'll multiply there, and we'll multiply the blue diagonal, and we set those equal to each other. So the yellow diagonal gives me 4x. The blue diagonal, I have to do 3 times 28. So 3 times 28 is 84. So I get 4x is equal to 84, and then I divide both sides by 4. And I get x is equal to 21. Number 8, very similar. Let me highlight the two triangles. And once again, I will refer to the smaller triangle as the older triangle, while I refer to the larger triangle as the new triangle. Okay, so the red one I will call old, and the green one will be the new. I am going to use x, of course. So I'm going to, instead of a question mark, I'm going to go ahead and call this x. Now be careful. Here's where the danger usually happens. This 2. A lot of students will accidentally try to use this 2 as one of the numbers in our equation, but please understand that the 2 is just this leftover little piece over here. Alright, 2 is not the side of any triangle, so the 2 will not show up in any equation that we're going to do. Instead, what's going to happen is when we need this side of the new triangle, the large green triangle, I will use the 2 to realize that this is 12. Alright, but I'm adding them up. I will not use the 2 in any equation. That's the big mistake that kids will make. Alright, so now we're all set. So as we always do, we will do new over old is equal to new over old for our proportion. So let's go ahead and use these sides first. New over old, that'll be 18 over x, alright, the green side over the red side. Okay, and then now we'll do new over old on this side, and we just found that the new side is 12, the total of these, and the old side is the 10, so 12 over 10. I like to reduce this fraction before I continue, so I will have 18 over x is equal to, these are both divisible by 2, so this will simply be 6 over 5. Now I will cross multiply. Okay, the yellow diagonal is equal to the blue diagonal. So the yellow diagonal gives me 6x. The blue diagonal, 18 times 5, okay, that's 90. And then I will divide both sides by 6. Okay, and that turns out to be 15. Alright, and that is it for problem number 8. Okay, problem number 9 is a little bit different because we have something called a midsegment. A midsegment is a segment that connects the midpoints of two sides of a triangle. And I know that U and T are midpoints because of the tick marks here. Alright, the double and the double, that makes U the midpoint. The single and the single makes T the midpoint. Special properties of a midsegment include the fact that the midsegment is always going to be half the length of the parallel side. Or I could say that the parallel side is double the length of the midsegment. Alright, that's going to be crucial. Let me just write down this word I keep saying, midsegment. So if I double the midsegment, alright, that should equal the parallel side. So that's what I'm going to do. If I double the midsegment, so 2 times the x plus 2, that should equal the x plus 11. Alright, this only works when it is a midpoint connector, a midsegment. Anyway, distributive property gives me 2x plus 4 is equal to x plus 11. I would subtract x from both sides right then. That will leave me with x plus 4 is equal to 11. And then just subtract the 4. So that gives you x equals 7, okay? Number 10 is going to be the same situation. Once again, we have a midsegment happening. So I can use the properties of a midsegment. Alright, the midsegment is half the size of the parallel side. If I double the midsegment, it should equal the parallel side. So that is what I do. So if I double the midsegment, that should equal the parallel side. Alright, this only works because S and R are midpoints. I can tell that from the tick marks. If I did not have these tick marks, I wouldn't be able to solve this particular problem. Anyways, distributive property. So 2x plus 36 is equal to x plus 27. Go ahead and subtract the x from both sides. That leaves me with x plus 36 is equal to 27. Subtract the 36 from both sides, and that's going to leave me with x is equal to actually negative 9. Negative 9. I guess they're just going to keep on giving us these easy peasy problems. When it's a midsegment, that just makes it so easy, because all I have to do is double the midsegment, set it equal to the other side, and I'm done. So 2 times x plus 15 should equal x plus 20. Don't have to do any proportions or anything. One more time, I only can do this when these are midpoints, which I can tell from the tick marks. Distributive property gives me 2x plus 30 is equal to x plus 20. Subtract that x from both sides, and I have x plus 30 is equal to 20. Subtracting the 30 from both sides, and I get x is equal to negative 10. Kabam! And it looks like we're going to finish it off with one last easy peasy mid-segment problem. Okay, so there's once again there's the mid-segment and the parallel side, and we know that if we double the mid-segment, that should equal the parallel side. So distributive property gives us 2x plus 4 is equal to 3x minus 3x minus 2. And let's subtract, I'm going to subtract the 2x from both sides just to keep the x positive. It makes me feel better. So then I will have 4 is equal to x minus 2, and then I will add 2 to both sides. So that's going to give me 6 is equal to x, or x is equal to 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.